All right, let's talk about friction. And friction is simply a force that opposes motion. So when two objects are trying to move past each other, friction is the force that slows that down, that opposes that motion. And there are multiple kinds of friction. You could have static friction. That's when the two objects are at rest and then you try to push them. It usually takes more to get it started going than it does when it's actually moving. You have kinetic or sliding friction. That's when they're already moving. You have rolling friction if you have wheels or something that rolls, a ball or something like that. You get a little bit different kind of friction there. And then you have fluid friction where an object is moving through a fluid like air or through water. And you can probably think about running through a pool or in a lake and how much friction that provides there. In here, we're going to talk mostly about kinetic or sliding friction. That will be the main ones that we're going to talk about. And friction depends on the surfaces that rub against each other. And if we want to figure out the force of friction, we're going to say the force of sliding friction is equal to the coefficient of sliding friction, which is simply a calculated number, and we could figure it out for different things. If we know like wood rubbing on wood, we can figure out the coefficient of friction, iron on iron, so on. We can figure out coefficient between these objects. And here's our formula. So that's the formula that we're going to use quite a bit. I'm going to put it down right here. We're going to say the force of friction is equal to this Greek letter mu times the normal force. And remember that we talked about the normal force is the force perpendicular to the surface that you are on. Now, if you're on the ground, on a flat surface, that would be the force, be straight up and down. That would be the same as your weight. But if you're on an inclined plane, then that's going to be a little bit different, and you would have to figure that out in a different way. Or you'd use some trig functions to figure that out. All right, so let's take a look at this example. It says Brian is walking through the school cafeteria but does not realize that the person in front of him just spilled his glass of chocolate milk. As Brian, who weighs 420 newtons, steps in the milk, the coefficient of sliding friction between Brian and the floor is suddenly reduced to 0.040. Notice that coefficient of friction has no label because you're comparing two forces, so the labels cancel. What is the force of sliding friction between Brian and the slippery floor? So if we want to figure this out, we need to figure out, we've got our information right here. Well, we know that he weighs 420 newtons. And if that's his weight, that's going to be, because he's walking on a level surface, that's going to be his normal force. So his normal force is 420 newtons. And the coefficient of friction is 0.040. So we would simply multiply those two numbers together, and if we multiply those together, we're going to come out with 17 newtons. So here's our new important formula. Force of friction is equal to mu times the normal force, and we're going to use that one in all of these problems here. All right, so that's the first one. Let's take a look at the next one. While redecorating her apartment, Kitty slowly pushes an 82-kilogram china cabinet across the wooden dining room floor, which resists the motion with a force of friction of 320 newtons. What's the coefficient of sliding friction between the china cabinet and the floor? All right, so we're going to start off with our formula. Force friction equals mu times my normal force, but we're given in here, or we're trying to find the coefficient of friction. So let's solve for coefficient of friction. That's going to be the force of friction divided by the normal force. If I divide both sides by Fn, I get that. So the force of friction would be the force that she applied, which I said was 320 newtons. And then we need to figure out what is the normal force. Well, they don't tell us what the weight is. Notice that they told us that it was 82 kilograms. Well, we want all of these forces in newtons. So what we need to do is take that times 10 meters per second squared, and that's going to give me 820 newtons. So now I'm going to take that and divide over here. 320 divided by 820 equals 0.39. That's my coefficient of friction. And once again, there is no label for that, so just leave it that way. All right, let's look at the next example. And once again, now we've got that wonderful inclined plane that we need to worry about. So at the zoo, a 900 kilogram polar bear slides down a wet slide and at an angle of 25 degrees to the horizontal. The coefficient of sliding friction between the bear and the slide is 0.0500. What frictional force impedes the bear's motion down the inclined plane? Alright, so once again, we're going to use force of friction equals mu times our normal force. And we know in this case they've given us mu is 0.050, and the force normal, they haven't given us that, but they have given us his mass, which is 900 kilograms. Alright, so let's draw our triangle, and our angle is 15 degrees, and I'm just going to use the box. And we know that he has a mass of 900, but if I wanted to figure out his weight, you know, that's going to be times 10 meters per second squared. That's going to be 9,000 newtons. So this is 9,000, but I need, this would be his FW, force of weight. But notice that's not part of my equation in here, but I have to use that to calculate the normal force. So here's my normal force. There's Fn. Remember, normal force is perpendicular to the plane that you're sitting on. So here's my plane, perpendicular to that. That's my normal force. Well, once again, remember we said that we know that these are similar triangles, so I can say that that's 15 degrees there. And if I want to solve for Fn, I can use a little trig magic, and I'm looking for the adjacent side, so I'm going to say, now let's do it this way, cosine of 15 equals the Fn over Fw, which is 9,000 newtons. Cosine of 15 and apparently that should not be 15. I just don't know how to read here. Sorry about that. That's 25. 25. So anyway, cosine of 25 times 9,000 gives me, for Fn, 8,160 newtons. So punch in 25 cosine times 9,000, I get 8,160. And now, if I want to solve for FF, that is going to be mu 0.0500 times 8,160, and that's going to give me 408 newtons. And there you have it. There are your sample problems.